In this section, we take derivatives of functions that can be thought of as a product of two simpler functions or a quotient of two simpler functions. In other words, these will be functions that will have pieces that are multiplied or divided. In order for the rules of this section to be applied easily, these simpler functions should be things that we find very easy to take the derivative of, things that we can use the power rule on. We'll use the names u of x and v of x, or just u and v, to describe those simpler functions. Let's take a look at an example. Here's a function, the quantity square root of x plus x squared times the quantity 5x cubed plus 2x. I want to write this as a product of u of x and v of x. So when I look at this, I see two pieces multiplied together, so the obvious answer would be u of x equals square root of x plus x squared, and v of x equals 5x cubed plus 2x. Now, since I can rewrite that square root of x plus x squared as x to the 1/2 plus x squared, that's going to be very easy to take the derivative of with our power rule. And the same holds true for v of x. So this is a good choice for a product. Let's take a look at another function. F of x equals the quantity 6x squared plus x divided by the quantity 3x squared minus x minus 12. And I want to write this as a quotient of u of x and v of x. So when I say a quotient of u of x and v of x, that means I want the u of x to be the function on top and v of x to be the function on the bottom. So if I let u of x equal 6x squared plus x and v of x equals 3x squared minus x minus 12, I've written that as a quotient. Notice both of these functions are going to be easy to take the derivatives of with our power rule. So now that we know how to break products and quotients into their separate pieces, now we need to talk about how do we actually go ahead and take the derivatives once I've done that.